Hello, my name is Jacob Saberman, and I'm presenting my application for this final project, which is a 3D pitch trajectory viewer. The scope of this project is to visualize a full three-dimensional pitch trajectory using real baseball data from Major League Baseball's 2021 regular season, which is publicly available on Major League Baseball's data website, baseballsavant.com. And the way this app works is there is this pitch trajectory tab here within the app, and that's where the plot would appear once the user has made his or her selections. These selections include choosing the pitcher from a drop-down menu here. So this will include all of the different pitchers who appeared in a regular season game in the 2021 season. Then user after that is able to choose their start date and end date, which dynamically filters based on the pitcher they choose. So the only options provided in this dropdown would be the dates of the appearances that the selected pitcher had appeared in during the 2021 season. And after those date ranges are selected, then there would be pitch type options down here. And again, this will be dynamically filtered as well, based on the previous selections to only show options for pitch types that the selected pitcher has thrown in between these two date ranges. Then there's a button here for the user to generate the plot visual. And really the way this works on the back end is the database is coming from a MongoDB non-relational database, NoSQL collection that is queried into the Shiny application here using R, specifically the MongoLite package. And that database was populated from a CSV from Baseball Savant's website, which includes pitch by pitch data. So there's one row for every pitch thrown in the 2021 regular season for over 700,000 total rows, which will obviously be heavily filtered down based on the user selections here. So the actual amount of data being inputted into the app gets filtered down pretty quickly into the user experience here. So just to give you a demo of how this works, let's say the user wanted to look at Shohei Ohtani's pitches. You can see the start and end date ranges will automatically filter. So these are all of Shohei Ohtani's 2021 pitching appearances. The start date automatically chooses the earliest date. The end date automatically chooses the latest date in the range. But if you wanted to only look at data from his April 4th start, you could do so. We'll keep it at the full date range right now. And then down here, we have the pitch types available plot. They're by default all selected. So we'll hit generate visual. And the visual is created using the Plotly package in R for its interactivity and its animation, which I will demo here. So here now we have a full three-dimensional pitch trajectory. This is based on a physics model using initial velocities and initial accelerations that come from the data itself, but then I created a physics model based on that to calculate the full three-dimensional trajectory. So you can see here, there's one path for each pitch type, a color legend up in the top right. So there's going to be 5 different paths here because we've selected 5 different pitches. Here on the right side, you can see this is where Shohei Ohtani would release the pitch. And then as it travels down to home plate, it obviously falls due to gravity and the pitch flight gets lower. So by default, it's set at this angle, which would simulate the batter's perspective. So Shohei Ohtani would be farther in depth here along the y-axis. And you can see how these pitches would come in. Also, a neat feature is the animation here. So if you were to hit play, these pitches would take you frame by frame. You could see them moving along their path. I kept the path static in the background while these pitches came in. So you'd see how each different pitch would find its trajectory from start to finish, and how they move differently from each other. One other feature in this application is this create a pitch tab. So in this area, a user would be able to come in and create their own pitch. So Shohei Ohtani, he doesn't throw a two-seam fastball. So if we wanted to create what a two-seam fastball might look like for him, we can name this a two-seam and then change these different pitch attributes to however we wanted to change them. And then by hitting save pitch to database, this machine learning algorithm would predict those initial velocities and accelerations based on these metrics for a model trained on the full 2021 data set. And then now having those initial velocities and accelerations would then calculate out the trajectory of the pitch. It would save the raw data back to the MongoDB database into the collection as a new entry. And then it would then add an option for this new pitch called two-seam in the pitch types. And then you'd be able to then visualize it in the pitch trajectory pane here. So that is the full scope of my app and all of its different features. Hope you enjoyed. Thank you.